Kickstart your software development career. Coursera and Amazon have partnered to bring you the Junior Software Development Professional Certificate, uniquely mapped to the key job skills required for junior software developer roles. This program offers a hands-on learning experience designed to prepare you for a rewarding career in this rapidly expanding field.
Each course in this certificate is designed and developed by subject experts to lay a solid foundation for future learning in this dynamic field. Throughout the professional certificate, you gain practical skills and hands-on experience through labs, activities, and quizzes. These opportunities will not only deepen your understanding, but also allow you to apply your knowledge in real-world scenarios.
Finally, you will have the chance to showcase your creativity and problem-solving abilities through a course project, demonstrating your readiness to tackle challenges in software development. In this software development program, you'll work on exciting, real-world problems that bring Java programming concepts to life. One of the projects you'll tackle is building a virtual zoo management system. This project is designed to test your coding skills while introducing you to essential software development concepts. Here's a brief overview of what you'll learn.
You'll begin by understanding the core responsibilities of a developer and setting up your own Java development environment. You'll learn Java syntax and structure to write and run your initial simple programs. For example, you might create a basic calculator that can perform arithmetic operations.
You'll also explore variables, which are containers for data, and data types, like numbers or text. And you'll learn about operators, symbols for calculations. This foundational knowledge will enable you to manipulate data effectively in your programs. For instance, you could write a program to manage a list of zoo animals and their characteristics.
Then you will uncover control flow mechanisms like conditional statements for making decisions based on conditions and loops for repeating tasks. This will help you write code to manage different scenarios. For example, you might write code to handle different animal feeding schedules based on the time of day.
What's more, you'll explore advanced techniques to keep your code tidy and easy to manage. Learning object-oriented programming, or OOP, principles will help you create flexible and reusable code. For example, you might create a general animal class that includes common attributes like name, species, and habitat. You'll also develop skills in understanding the entire software development lifecycle and various methodologies used in the industry. Imagine you're organizing a big concert with your friends. You'll learn how to plan each step, from booking the venue to managing the guest list, similar to how you would manage each phase of a software project. This way, you'll know how to keep everything on track and ensure the concert or your software project is a success. Moreover, you'll gain proficiency in Git, enabling you to manage version control, track changes, and collaborate effectively on projects. For instance, you'll learn how to use Git to keep track of different versions of your code and work on team projects without conflicts. Later on, you'll create full-stack web applications, integrating server-side logic and front-end technologies, preparing you for real-world web development tasks. For example, you might build a web application that allows users to view and interact with your virtual zoo online.
Lastly, you will gain insights into implementing generative AI tools for task automation, further expanding your skills and keeping you at the forefront of modern software development. For instance, you might learn how to use AI to automate the generation of animal feeding schedules based on various factors. Throughout the program, you'll use tools and techniques that are standard in the industry, preparing you for real-world software development challenges. Get ready to dive into Java programming and build something amazing with your newfound skills.
So gear up, grab your laptop, and let's make some magic with Java. Who knows what you'll build? To be successful in this program, having some coding experience can give you a head start, but it's not a must-have. We recommend having a fundamental grasp of programming concepts and an openness to learn and develop your skills. The demand for software development professionals is on the rise. The United States Bureau of Labor Statistics anticipates a 25% increase in jobs by 2032. In today's digital age, software drives innovation across industries, making foundational software development skills essential for career advancement and success.
Join us to gain a competitive edge in securing software development internships or advancing your technical skills within project teams. Amazon, known for its innovation and technological leadership, brings a wealth of practical knowledge to this program. Amazon software developers are instrumental in creating customer experiences, designing architecture, and implementing products used by millions worldwide. By partnering, Coursera and Amazon leverage their respective strengths to create a powerful learning experience for aspiring junior software developers. This collaboration combines Coursera's flexible, high-quality content and interactive learning experience with Amazon's real-world technological expertise.
The primary advantage lies in acquiring practical skills and knowledge essential for launching a career as a junior software developer. This professional certificate not only equips you with the expertise needed for entry-level roles, but also provides a recognized certification, bolstering your credibility within the industry. This credential can significantly enhance your prospects for securing internships or apprenticeships, offering hands-on learning experiences under the guidance of seasoned professionals. On completion, you'll possess the skills and knowledge needed to develop software applications independently, troubleshoot technical issues, and collaborate effectively in software development teams. Additionally, you'll receive a professional certificate that can bolster your resume and career prospects in the tech industry.
Wondering what makes this program stand out? Here are some unique features that will benefit you. Online assessment preparation. Get ready to excel in online technical assessments used by top companies in their job interviewing process. Insights from Amazon software developers. Gain valuable first-hand knowledge and practical insights directly from seasoned Amazon software developers.
Embark on your journey to a rewarding career in software development with a program that equips you with the skills and knowledge needed to succeed in the tech industry. Get excited, get started, and get ready to make your mark in the world of software development. Imagine developing a calendar application that needs to store data for every day of the year. Creating a variable for each day is possible but inefficient. So how can you do it efficiently? In this video, you will learn about arrays, a basic data structure for efficient data management, memory optimization, and writing clean, maintainable code. An array is a fixed-size linear data structure that stores elements of the same type in a single container. They can be one-dimensional or multi-dimensional, but let's focus on a one-dimensional array for now. A one-dimensional array is like a list of elements, all of the same type, arranged in a single row. You access each item using a single index, such as days of the week. Crucially, these indices start from 0. Earlier in the video, you learned that creating a variable for each day of the month or year is possible but inefficient. Here's why. Declaring 31 separate variables for each day of the month means writing many repetitive lines of code, which would entail updating variables multiple times. Additionally, it could incur possible scalability issues if you need to introduce other variables such as months or years. And finally, it would reduce code readability and increase the chance of making errors. So instead of creating separate variables, you can use an array. Declaring an array in Java allows you to create one variable with many values. This method manages memory efficiently and adds flexibility. Let's explore how to declare a string array. The keyword string defines the data type, and the square brackets indicate an array. In this example, the word string is followed by square brackets, while the variable, days of week, instructs Java to create a string array without specifying its size or values. You can also declare an array with square brackets after the variable name. In this example, the word string is followed by the variable, and then the square brackets. There are two main ways to initialize an array, statically and dynamically. Let's start with static initialization. Consider a scenario where you want to represent the days of the week. The easiest way to create this array is by using an array literal, which allows you to define the values directly while declaring the array. This method is known as static initialization. In this code, the array days of week is initialized with the days of the week using curly braces, with each element separated by a comma. This approach is ideal when you know all the elements you want to include in advance. Now, suppose you want to create an array for the days of the week, but plan to add the days dynamically, perhaps filling the array later in your code. In this case, you would use dynamic initialization. Here you declare an array with a specified length and then assign values to each element as needed. This method is particularly useful when the elements of the array are not all known at the time of declaration or need to be computed or retrieved from another source. Let's extend the idea of dynamic initialization with the days of the week example. Suppose you want to create an array to hold the names of the days dynamically, using a loop to fill it. Here's how you could do it. In this code, the days of week array is created with a length of 7. Then, using a loop, each element of days of week is populated with the corresponding day from the days array. In this example, an empty array called positive numbers is created. Then a loop is used to fill it with values. Let's now explore how to access arrays. You can access elements through the index or by iterating over the array using a loop. Remember that indices start at 0. Let's start with using an index. You can easily access the required element when you know the position or index number. For example, to get the first element of the days of week array, use days of week and 0 in square brackets. This will return Monday. For the fourth element, use days of week 3, which returns Thursday. If you want to access an array's last element and don't know its total length, just pass the length of the array minus 1. In this case, it will be days of the week minus 1, all in square brackets. Remember, the square brackets indicate the array. The loop is the most suitable option for accessing all elements in an array because it lets you go through each item one by one without writing the same code again. For example, if you want to print each day of the week, you can use a loop to iterate through the array. Arrays help manage data efficiently, optimize memory, and write cleaner code. Think back to the calendar application. Using an array, you can store all the days of the month in a single structure, making it easy to access and update each day. Arrays can help you manage data structures like calendars more effectively. They provide a simple way to handle large sets of related data, reducing the complexity of your code. As you continue to explore Java, you'll discover robust data structures and algorithms that will elevate your coding skills. Arrays are your first step on this journey. Imagine using a calendar application that prevents you from creating new events. This would be very frustrating for your users. Applications like this must be able to modify and manage their data effectively to function well. Arrays are a fundamental way to handle such data, but you need to know how to perform operations on them to make the application usable. In this video, you will learn how to perform 3 primary operations on arrays: traversal, insertion, and deletion. Let's start with traversal. Consider the calendar application again. Imagine you'd like to browse different days, weeks, or months to view your schedule. Traversals allow you to navigate your schedule and find out what's planned. It is the process of going through each element in the array one by one. It is a straightforward process and is typically achieved using loops. Here's how it works in Java. Declare an array of strings named day of week. The curly braces initialize the array with the values Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Then a single line comment explains the code related to initialization. You initialize a for loop by declaring and initializing the control variable I, which starts at 0 and continues to iterate as long as I is less than the length of the day of week array. In each iteration, I is incremented by 1. Finally, print out the current element of the array. Now let's explore insertion. Suppose you want to add new events to specific days and times. Without insertion, you won't be able to schedule anything. Insertion refers to adding a new element to a specific index in an array. However, inserting an element into an array can be challenging because arrays have a fixed size. Insertion can be approached in 2 ways, either by adding elements without changing the array size or modifying the size to accommodate new elements. For example, if a calendar app uses a fixed-sized array to store daily events, you must know how to add new events without exceeding the array's maximum capacity. This ensures efficient scheduling within the array's predefined size. On the other hand, if the array needs to hold more appointments than expected, resizing the array dynamically keeps the application flexible and responsive to user needs. Let's explore an example. Imagine you've defined an array with a fixed size of 7 for 7 days of the week and want to insert an element at index 3. Since the array doesn't require altering its size when the insertion index is within the size limit, an element can be inserted without changing its size. You can now modify it with a new element. In this case, replace Thur with Thursday. Now imagine you have an array with 5 months of the year and need to add another month. This requires increasing the array's size. The position where you insert the new element, beginning, end, or middle, affects how you rearrange the existing elements, because inserting at the beginning or middle requires shifting elements to make space, while adding at the end does not. Finally, let's consider deletion. Deletion refers to removing elements from the array. Unlike modification, deletion affects the array size, because traditional arrays are not dynamically resizable. As a workaround to maintain the original array size after removing an element, you can replace the specific element with null. This keeps the overall size of the array unchanged. But what if you want to delete an element by altering the array size? In this scenario, like insertion, you would create a new array and copy all other elements except those you want to delete. Don't worry about that logic just yet. Simply understand that a new array is created and elements are copied one by one using a loop, excluding the element at the index you want to delete. Working with arrays is an essential skill for programmers. Here are a couple of key points to remember when working with arrays. Inserting or deleting elements in the middle of an array requires extra memory, which is not always the best solution. Deleting and replacing elements with null values can waste memory because the array size remains unchanged. If not appropriately handled, this can lead to null pointer exceptions. Later in the course, you will learn more efficient programming techniques to avoid these issues. Mastering these array operations ensures you can build robust applications when you enter the professional world. Imagine you're buying tickets to a highly anticipated movie online. How does the system show you which seats are available in real time, even as hundreds of others are trying to buy tickets at the same time? This magic happens with the help of arrays. You've already learned how to declare, initialize, and manipulate arrays, but now let's understand where they truly shine in everyday scenarios. In this video, you will learn the specific use cases for arrays using real-world examples. They include data collections with fixed sizes and when efficiency and memory management is required. Think about the calendar application you've been working with. When building such an application, you would need to keep track of dates, weekdays, and events throughout the month. To build it efficiently, you'd use arrays. An array can hold the days of the week, making it easy to access any specific day. For example, if you want to find the third day of the week, you simply use days of week. And since arrays always start from 0, days of week at position 2 will give you Wednesday. Consider the scenario we introduced at the beginning of the video, buying tickets online. How can arrays be used if, say, only 100 seats were available? How do you track which seats are available and which are booked? With an array, of course. Each seat corresponds to an index in the array. For instance, seat 0 is the first seat, seat 1 is the second, and so on, up to seat 99 for the 100th seat. If you want to check if seat 50 is free, just check seat 49. Arrays provide an efficient way of handling data because they store elements close together in memory, making it quick to access any item. Plus, they don't waste space. Each element has its spot. Here's an example to illustrate this. Let's say we're building that calendar application, and in Java, you've written a string array with days of the week, Monday to Sunday. To find Thursday, you simply use days of week at index 3. Remember, arrays start at 0, so index 3 gives you Thursday. Efficient, right? Now let's apply this to the seating example. How do you choose the right data type for the seats to minimize memory usage? You could use an array of integers or booleans. An array of integers might seem like an easy choice, where each integer shows whether a seat is empty, indicated by 0, or occupied, indicated by 1. But keep in mind that each integer usually takes up 32 bits or 4 bytes of memory. If you have a lot of seats, this can use up a lot of memory quickly. On the other hand, using a Boolean array is much more memory efficient. A Boolean only needs 1 bit to show 2 states, true or false, representing whether a seat is occupied or empty. So, using a Boolean array can save a lot of memory compared to using integers. Each element represents a seat. For example, seat 0 is the first seat, and seat 1 is the second, and so on. If you need to check if the seat number 60 is available, just check at seat 59. So, why are arrays preferred in these scenarios? First, they have a fixed size. This makes them perfect for applications like a calendar or a seating chart, where the number of elements doesn't change. In other words, their positions are fixed. This makes your code clean and efficient, especially when looping through each day to display events. Arrays are also easy to access. Each element has a specific placement, so finding any item is fast. This is crucial for performance-critical applications, where quick updates and checks are necessary. And finally, arrays are efficient. They store elements close together in memory, which means accessing or updating any element is quick. This makes them ideal for applications that need to run smoothly and efficiently. To sum up, arrays are ideal for managing static collections of elements, like the days of the week. They are fixed size, easy to access, and efficient regarding memory and performance. So, next time you're building an app that needs to store a fixed set of items, remember the power of arrays.
Hi, my name is James Karai. I'm a software engineer at Amazon. A normal day for me is a lot of coding, a lot of code reviews, and a bunch of meetings. And the meetings are all kinds of things like design reviews, planning for future projects, mentorship and career development, things for the people I mentor. For my team, the tools and technologies that we use are Java and Python, for sure. Those are really important for our tech stack. And also, of course, being at Amazon, we use AWS technologies extensively. Beyond that, we have the freedom to use whatever tools we need to debug and assess and research, which makes the days very interesting for sure. I think my biggest advice for people that want to get into the field would be make sure you're doing it because you're interested in it. Today, there are millions and millions of software engineers at all different kinds of levels of involvement. So people can learn really high-level technologies and not understand the lower-level implications. So it can be really overwhelming if you want to break into the field. Like, do I have to learn everything, or what's important? But if you're not interested in getting into the weeds, I think it'll never be fulfilling as a job. So that's really important. Staying up to date with the latest technologies is one of the biggest challenges of being a software engineer. So much of our job is reading documentation and making sure we have the latest version, or we're up to date with the most proper tool for the task. A big part of that is just the day-to-day job. So it's okay to spend your work time learning new things and staying up to date with the latest updates to the tools you have. Mentorship's super important in software engineering everywhere, as well as it's a priority at Amazon. So for me personally, I'm a mentor to junior engineers and to interns. The biggest thing I've learned from mentoring is that everybody needs support in different ways. Some people need technical advice, how to make design decisions, which are tough to know the answers to if you've never gone through the steps. So for me, it's trying to understand, okay, do people need more support, or should I give them some space to figure things out for themselves? At a big picture view, software engineering and the products of software engineering are ubiquitous in the modern landscape. So more than just big tech companies, right? Almost everything that we interact with on a day-to-day basis is some product of software engineering. As a result, it's important for software engineers, both leaders of industry and regular people working on these products, to take stock of that and to be good stewards of society as we build products that people use every day for little things like opening their garage and making sure their fridge works, right? As well as big things like running a large tech service that companies rely on. I think some of the toughest projects that you work on as a software engineer are the ones where you don't expect them to be so tough. So you maybe underestimate the scope, or things change, midway through. Every project has its obstacles to overcome, but the most important thing is making sure to communicate with stakeholders and to roll with the punches, really.